Hello students, the day is Monday and we are going to be looking at a topic of interest. It is the last topic before our test, before we break for a review. However, this topic will not be on the test. We do have tonight to add to our trig knowledge, so we'll pick up with that after the test and build on it. And since you are such a terrific trig class, I'm going to show you a picture of terrific. Whoops, there. Now it's terrific. So part of our lesson today, we'll see something that looks sort of like that. So, oops. All right, so I will get rid of this and show you a clip from that if I can find it. Come back to me, little clip.
How about terrific?
Cut that down to one terrific, and it might do very nicely. I think terrific will impress Zuckerberg.
But Charlotte, I'm not terrific.
You're terrific as far as I'm concerned.
We'll see how to spell it, and then we'll cut the clip.
Does anybody know how to spell it?
I think it's T-E-E-I-I-I-I-I-C-C-C.
Alright, let me try that.
Do you think?
Alright, for my terrific trig kids. Double T, double E, double R, double I, double F, double F. I think she doubled two of them. Double I, double C. Okay. Do I make the point? It's a terrific trig class. Alright, you'll see how that little web idea will tie into our lesson. And we are going to be graphing trig functions. Specifically, we are going to be graphing the sine and the cosine curves. The sine and the cosine curve, which you will find to be terrific. Graphing sine and cosine curves. Up here I wrote graphing trig functions, but we're only going to get to the sine and the cosine today, so that would probably be a more appropriate title. Let me time this. I've already used up 5 minutes of blab, so let's see what's left. I'm going to give myself about 10 minutes before I turn to part 2. Alright, in order to understand the graph of the sine curve, that little sound there is the teapot. Get the teapot. Alright, there's somebody boiling water here, so don't be alarmed. Let's look at the unit circle. And the unit circle has some secrets in it about graphing the sine function. So I'll just put in some 6, and here's one of them. So if you recall, the coordinate here is 1, 0, and here it's over square root of 3 up 1/2. And I'll skip the quarter. I'll go up to the pi over 3. So that is 1/2 square root of 3 over 2. And then this one is 0, 1. And I'll skip to the quadrangles. This is -1, 0. And this is 0 minus 1. Alright, so that gives us, we're used to that. And I think it would be helpful if I knew this value. So let me switch over to my phone and get that. Square root of 3 over 2 is exact, but to get a decimal view of it, let's see, 3 square rooted is that divided by 2. And I get 0.87, we'll say. So this is 0.87. That's what square root of 3 over 2 is. It's about 0.87. So that'll help us today. We normally don't need to know that. All right, so let's say I'm looking at the sine curve. So I'm going to title this graph y equals sine of theta. And I'm going to put theta on the x-axis. And so that's where I'm going to put theta. So theta will be on the x-axis, and this will be y. And I need to find my timer again, just a second. Okay. I'm looking over here at the unit circle, and I'm interested in the value for sine. So what is the value for sine at 0? In fact, I'm going to graph the 0 value at sine. I'm going to graph pi over 2, which is this one right here. I'm going to graph pi, and that's this one over here. And I'm going to graph 3 pi over 2. And then I'm going to go back to 2 pi. Let me get this x theta out of here. You know that. So this was 3 pi over 2 and 2 pi. So looking at the values here, remember sine is the second coordinate. So we start out, when we have a sine of 0, we are at 0. So the point 0, 0 is on the graph. And I notice it goes up to 1/2, and then 0.87, and then to 1. So just looking at the second coordinates, look at them graphically. Remember, we go over the x value and up the y. So I'm interested in this value. Notice how this one is larger. So we go from 0 to this one, to a larger one, to this one. And then what happens on the other side, without seeing the number coordinates, we can see this is the y value, shrinks back down. So we start at 0, and it increases in size and then decreases. So I expect that to show up on my graph here. So from 1, 0, it goes to, let's say this is 1 right here. So it's going to go from 0 to 1/2. And then it's going to go to 0.87, and then it's going to peak right here at 1. So what happens on the other side of pi over 2? Over here, let's just go all the way over to pi radians, which is here. It goes back down to 0. So over here, we end up back at 0 again. So it's going to go up and increase. It'll peak at 1. There's no sine function on the unit circle larger than this length. So, and then it's going to go back down to 0 through the same numbers it went up through. And then what happens when we get down to here? When we get around to 3 pi over 2, we're at -1. So coming back here, I'm going to graph at 3 pi over 2. If this is 1, we'll call this -1. And we'll be back down. And at 2 pi, we get back to 0 again. So you see this rhythmic rise and fall and rise again. And that's the typical sine curve, and we call it y equals sine of theta. It doesn't really start and end at this point, because we could go around again, or we could go in the negative direction. So this graph will continue in like manner continue up and down, up and down. Notice the highest point is 1, and the lowest point is -1. So it never goes higher than this or lower than this, and it continues to repeat over and over. So that is the sine curve, and there's some aspects about it I would like you to know. This is the equation, and we talk about the amplitude. The amplitude for this function is referring to the line that cuts the equation horizontally in half, the center line right here. This is the line over which the function rises and falls. So the amplitude is going to be the distance from the center line to the highest value, that distance right there. And we can read that over here, and we can see that that is 1. You can also find the amplitude here. It's the same, ignoring the sign, the SIGN. It's the distance from the center line to the lowest point. If we call it a distance, which is going to be positive always, it's also 1. So we say the amplitude, spelled that wrong, amplitude. The amplitude is 1. And then the other aspect we need to understand about the sine curve is called the period. And the period, it refers to how many radians does it take for the sine curve to complete one cycle. So one cycle is one mountain and one valley, and then it starts to repeat itself. So that is called its period. So it started here and it ended here. So we say the period is 2 pi. So it doesn't matter where we look for the period. We could look for it from peak to peak. So if we started at the peak, went down the valley, and back up to the peak, that would also be a measure of the period. But you would see, if you had this number, you would see it was also 2 pi. So any point on the sine curve to the exact repeated point on the sine curve is going to be 2 pi radians away. So before I switch to the cosine curve, I just want you to be aware that this can be thought of in degrees, and we do that. This is 90, and this is 180, this is 270, and this is 360. So just be aware it can be thought of. It's usually in radian measure, so I wouldn't cross these out. I just sort of make a note that they are also seen in degree form as well. All right, let me shut that down and introduce you to the cosine curve.